Not often. Okay, greatest common factor. That's what 38 and 39 is about. Okay, factoring is important because it's another way to solve equations. When you get more complicated than linear equations, you need other methods. Factoring is one of them. So there are multiple steps. It's very, very important that you understand how to factor. The first thing you're going to do, and I'm going to put this on the yellow page first, okay? This is a factoring flowchart. It's going to take us multiple days to get through it because we're only teaching you step 1 today. Step 1 that you do when you want to factor is you take out the greatest common monomial factor. So monomial means 1. So the one thing that you can take out that everything can evenly divide by. So what you ask yourself, I just told you, what can you divide each term by evenly? So like for instance, if I have an 8 and a 4, what do 8 and 4 both divide by? 4 or 2, okay? That's what I mean. Does 8 and 4 both divide by 3? No, so that would not be a common factor. Things that multiply to get those numbers is what that means. All right, if all terms, now you're also going to have terms that have variables. So I just told you an 8 and 4, those are only numbers. You're also going to have things that have x squareds, x to the third. So if all terms have the same variable, you're going to look for the lowest exponent. And that's all part of the greatest common factor. Okay? All right, so I should say up here what is the highest number you can divide each term by evenly, because we want the greatest common monomial factor. So I should have said how, like, what is the greatest number you can divide by. Okay? But you'll catch on, I think so, on this other side. All right, the rest of this, if there is yes, then you write your greatest common factor out in front. So your problem would look like greatest common factor, and then you would have sets of parentheses with things on the inside. Okay? So that I'm just showing you, so hopefully that will trigger, oh yeah, I remember what that's supposed to look like. Now, you might also have something that doesn't have a greatest common factor. If it doesn't have a greatest common factor, then you just move on. Okay? All right. So we're saving the rest of the flow chart for another day. The only part we're doing is this first step today. All right, so here we go. Factoring reverses multiplying. Factoring reverses multiplying. So steps for factoring the greatest common monomial factor, which means greatest common monomial factor. Step number 1, you find the greatest common factor. So find the greatest common factor. Then you write the greatest common factor in front. Then you put an open parenthesis. Then you're going to divide each term by the greatest common factor. And then finally, you can check by multiplying. All right, so those are kind of like your steps that you're going to follow to get the greatest common factor. So let's go ahead and try a few. All right, so number 1, y'all ready? So we're going to take, let's say we have a question that says 2x minus 8, and they are asking us to factor. Okay? So first thing you're going to do is look at your numbers. I see a 2 and I see an 8. What can you divide 2 and 8 both by? 2. That's the biggest thing. And now, do they all have x's? No, so they do not have x in common. So the only greatest common factor, leave a little space. The only greatest common factor is 2. So you write a 2 and then you put a parenthesis. And now you take the 2 and you divide each of these by 2. So you're going to put divide by 2, divide by 2. Okay, so this is like your work. This final line right here is going to be your answer. What's 2x divided by 2? Yeah, the 2 and the 2 cancel. So you're left with what? X. What's 8 divided by 2? 4. So it's x minus 4 on the inside. And that would be the answer, but I told you on step number 4, check by multiplying. So here's what you want to check. Does 2 times x give you 2x? Does 2 times negative 4 give you negative 8? Yeah. Remember how your homework on 5-1 gave you this and wanted you to come up with that for an answer? We're doing the opposite. We're reversing the process. All right, let's try number 2. This is going to get a little tougher. So number 2 says 3x to the 4th plus 4x squared. 3x to the 4th plus 4x squared. Okay, so first look at your numbers, a 3 and a 4. Can you divide a 3 and a 4 by anything? 1. 1's the only thing you can divide them by. If it's 1, you don't have to write it. Because 1, does 3 divided by 1 change? No, it's still 3. All right, do they all have the same variable? Yes, they all have x. You want the lowest exponent. So which one's the lowest exponent? See how they both have x's here? X squared's the lowest. So you would put x squared out in front. And then a parenthesis. And now you divide each of the terms by x squared. So divide by x squared, divide by x squared. Okay, you got to go back to Algebra 1 and think about how to divide exponents. A 3 divided by a number 1 here, does that do anything? No, you still have a 3. How about x to the 4th divided by x squared? Does anybody remember what you do with your exponents when you divide? Subtract. Good. You subtract. What's 4 minus 2? 2. So you get 3x squared. Okay. What is 4 divided by, there's a 1 here, but you don't see it. What's 4 divided by 1? 4. So you put plus 4. And 2 minus 2 for your exponents, I'll do what? Subtract, and they cancel, so they're gone. X squared over x squared cancel each other out, so that is done. That's your answer. Okay, if you want to check that one, you add exponents when you multiply. So does x squared plus x squared give you x to the 4th? Yes, because 2 plus 2 gives you 4. All right, let's keep practicing. I'm going to